Hello, hi students. Myself Mubarak. In this lecture, we are going to discuss about Acyloin ester condensation reaction. Before going to discuss about Acyloin ester condensation reaction, we should know what is meant by an Acyloin is. So, Acyloin is any organic compound which contains an hydroxyl group adjacent to the ketone group. So that type of compounds we can call it as an Acyloin. So here you can see one example here. So here you can see an hydroxyl group was adjacent to the ketone group. So this part we'll call it as the ketone group. So here hydroxyl group is there on the adjacent carbon of the ketone group. So that is why we'll call it as an Acyloin. So this OH group is present on the alpha carbon atom. So we can also call it as the alpha hydroxyketone. Acyloin is also called as alpha hydroxyketone. Reason is alpha to the ketone group you are having the hydroxyl group, that is why alpha hydroxyketone. So we can also call it as Acyloin. So coming to the reaction, so in Acyloin condensation reaction is a bimolecular reductive coupling of the two esters using the metallic sodium to yield alpha hydroxyketone, so which is known as an Acyloin. So here we are going to prepare the alpha hydroxyketone from the carboxylic ester. So here you can see the ester. Starting from the ester, ester will react with the sodium in presence of the in inert condition to form an alpha hydroxyketone. So here you can see the final product Acyloin. So the reaction is more successful when R is an aliphatic and saturated. So if you are taking the alkyl group, an aliphatic alkyl group and saturated alkyl group, so the reaction will give the more percentage of Acyloin. So instead of an alkyl group, if you are taking the aryl group, that reaction we'll call it as the benzoin condensation reaction. So this reaction will be carried out in the aprotic solvents like benzene, toluene, etc. You have to use this reaction in aprotic solvents where there is no donation of the proton happens. So if you are using the proton solvent, that reaction is not called as an Acyloin condensation reaction. Product is not an Acyloin. That reaction name is called as Bouvelt-Blanc reduction. So in this reaction, alcohol is the main product. Coming to the mechanism of the reaction, the first step is sodium initially react with the ester to give the radical ion. So here you can see the two molecules of an ester. So two molecules of ester react same pattern with the sodium. Sodium is having the one unpaired electron. So one unpaired electron will be donated to the alpha carbon. So carbonyl carbon. So that pi bond will get polarized towards the oxygen. So because of that, oxygen will get the negative charge and this carbonyl carbon will get the positive charge, and one more extra electron was donated by the sodium to the carbonyl carbon, and sodium will comes out in the form of Na+. So after giving the one electron, sodium will get the positive charge. That positive charge was accepted by the oxygen atom. So this is called as the radical ion. So why we'll call it as the radical ion? Reason is, so in this molecule you can see both you're having the radical on the carbonyl atom as well as the anion on the oxygen. So now you'll get the two molecules of radical ion. The second step is the radical ion dimerizes to form the dianion. So here you can see the two molecules of the radical ion. Okay, so here you're having one electron, so both electrons are like this. So this both electron with single electron will get paired up and you will get the new sigma bond between these two carbon atoms. This you will get the new carbon-carbon linkage. So you can see here. So this is the new carbon-carbon linkage. So we can call it as the dianion. So why I am calling it as a dianion? Because on oxygen you are having the two negative charge, that is why we are calling it as an dianion. So this dianion, by the release of the two alkoxide from the radical ion, a diketone is formed. So now what happens? The two alkoxide groups. So here you can see the first alkoxide. So alkoxide will take the 2 electrons. So between the alkoxide and the carbon, you are having 2 electrons. So 2 electron will comes along with the methoxide, and you will get the positive charge on the carbon and the negative charge on the oxygen. So minus OMe. So methoxide ion will come out. So because of positive charge on the carbon, so you will get the double bond here. So you can see the one double bond is formed between carbon and oxygen. So again the second methyl group also will come along by taking the 2 electrons. So methoxide ion will come out, and the negative charge on the oxygen and the positive charge on the carbon will form the new double bond. So here you can see, here it is a newly formed double bond, and here also it was the newly formed double bond. So here you are having the 2 ketone group in the molecule. That is why this molecule is called as diketone. So what is the second step? The radical anion so dimerizes to form the dianion. So the dianion, by the release of the 2 alkoxide, it forms the diketone. The third step is diketone further reacts with the sodium to form the dianion. So here you can see the sodium atom which is having one unpaired electron. So it will donate that unpaired electron to the carbonyl carbon. At the same time, this pi bond will polarize towards the more electronegative oxygen atom. So oxygen atom will get the negative charge, and carbonyl carbon will get the positive charge, and anyhow sodium is giving one unpaired electron. The same thing will happen. Sodium will give the unpaired electron to the carbonyl carbons, and pi bond will polarize towards the oxygen. So oxygen will get the negative charge, and the carbonyl carbon will get the positive charge. So you can see here the two radicals are there on the 2 carbon atom, and you are having the 2 negative charge on the oxygen, so which was nullified by the 2 Na plus ion. So after giving the sodium 1 electron, so Na will come out in the form of Na plus. So here also you can see Na is coming out in the form of Na plus. So one molecule of diketone react with the 2 moles of sodium atom to form the dianion. So you can see here dianion. So these 2 radicals both will pair up to form the pi bond. So here you can see the new pi bond was formed. New pi bond was formed after the pairing up of the unpaired electrons on the each carbonyl carbon atom. The fourth step is aqueous workup. Okay guys, this dianion, so after workout with the water, it will give an alpha hydroxyketone. So you can see here you are having the dianion. Okay, so after adding the water, this Na plus ions will get replaced with the H plus. Here you can see the diol, so which undergo ketoenol tautomerism. So one hydrogen, so this hydrogen will get transferred to this carbon. Okay, so pi bond will get transferred here. So you have got an alpha hydroxy ketone. So final one is Acyloin. Final is Acyloin we have got. For example, in this reaction, you can see the 2 esters are there in the same molecule. So here this happens intermolecular reaction. It happens inside the molecule. For example, I will show here. We will write the mechanism of the reaction. Okay, so here you're having C double bond O ET, C double bond O ET, and here also you're having C double bond O ET. So ET means what? Ethyl. So this react with the first molecule of the sodium. So what is the role of sodium? Sodium is having an unpaired electron. Sodium will donate its unpaired electron to the carbonyl carbon. At the same time, so pi bond will polarize towards the oxygen. The same thing will happen with the another ester. Sodium is having one unpaired electron. That unpaired electron will be donated to the carbonyl carbon, and the pi electron will get polarized towards the oxygen. So oxygen will get the negative charge, and the carbonyl carbon will get a radical in it. So first step is formation of a radical ion. So you can see here. Okay, so on oxygen you will get the negative charge again. So on this you are having OET. The same thing, the second molecule of the ester will oxygen will get the negative charge. Here you are having the OAT, and both will have the 2 radicals. So this is called as a radical anion. So what is the next step? radical anion dimerizes to form the dianion. So you can see here these two radical anions, so both are having one unpaired electron. This two electron will get dimerizes and you will get the new sigma bond between the two carbon atoms. So the ring closing will happen here. So you can see this is the new sigma bond. So on this carbon atom you're having the oxygen with the negative charge. Again on this carbon atom you're having oxygen with the negative charge. Same, so this carbon is having OET as well as this carbon is having OET. So it leads to the formation of what? Dianion. So dianion was formed in the reaction. So what is the next step? Next step is that dianion will lose the two alkoxide ion and it will form the diketone. So here you can see between the ethoxide and the carbon you're having the two electrons. So two electron will get polarized towards the oxygen and this carbon will get the positive charge. At the same time here between the ethoxide and the carbon the two electron will be polarized towards the oxygen. So this carbon will get the positive charge. It leads to the formation of the diketone. So here diketone will be formed. So now this diketone again further react with the two molecules, so two atoms of the sodium to form the dianion back. Okay, so it forms the dianion like this. You can see here after so dianion will form like this. So after formation of the dianion, so working out with the water, so it will form the diol. So the sodium will be replaced with the hydrogen. So finally, after keto-enol tautomerism, so one of the hydrogen will be transferred. So you can see here, so one of the hydrogen will be transferred to the carbon, and you will get an acyloin. So you can see this is an alpha hydroxyketone. So for example, in this molecule also same mechanism. I will write the open structure of the molecule. So you're having C double bond O, OH, C double bond O, OH. Okay. The same mechanism when it reacts with the sodium, first it forms a diradical. Final. So final product is this. It forms the. So this is the final product. So you can see this example here. So from this example you can prepare n-paracyclophanes. Okay, so this is the n-paracyclophane. First of all, when I'm reacting the ester with the sodium, so here what happens, Acyloin condensation reaction. So you can see here there is the formation of the Acyloin. So ring closing was happened. So this Acyloin after reduction with the zinc with HCl, so what happens, this OH will get replaced with the H, and this COOH will be this oxygen on this CO will be replaced with 2H. Total you can have 3 CH2s are there here, one here, and one CH2 is there here, another 4 CH2 is there here. Total how many number of CH2s? 4 plus 1 3, 3 plus 1 4, 4 plus 1 5, 5 plus 4 9. So total you are having the 9 CH2. So this is called as the paracyclophanes. Okay, so very simple. So what is meant by Acyloin reaction? In Acyloin reaction we are going to convert an ester into the alpha hydroxyketone by using the sodium in presence of an inert medium like toluene you can use, xylene you can use. Okay, so which is not the proton donor, all the solvents you can use. If you are using the proton donors, that leads to the reduction reaction of the ester, so where alcohols will be formed, you will not get an alpha hydroxyketones. So with this we have completed Acyloin condensation reaction. Thank you very much.